David Smith here with another flipped classroom math video. Today's topic, two topics, negative bases and also prime factorization. We're talking about exponents and indexes and powers, all the same, those three words. Okay, so negative bases. This means something like this. So this is negative 2 to the second power. So what that means is negative 2 times negative 2, which in this case, we have two negatives times each other, so that makes a positive, and it's 2 times 2, so we get positive 4. Okay? Let's look at another one. How about negative 2 to the third power? Okay? You know how to write this out already. Negative 2 times negative 2 times negative 2. The result's going to be a little different. Now we have a negative times a negative. That would make that positive, but then we're going to multiply it by one more negative, so it's going to go back negative. So my answer is going to be negative, and it's 2 times 2 is 4, times 2 is 8. So this one is negative 8. So I'm going to give you one to try. See if you can figure it out from this pattern. Negative 2 to the fourth power. Pause the video. Okay, let's see how you did. This one is negative 2 times negative 2 times negative 2 times negative 2. So in this case, the answer is going to be positive again. These two make a positive number, but then we multiply it by a negative, so it would go negative, just like this one. But then we're going to multiply it by another negative, so it's going to go back positive. And we know that 2 times 2 times 2 times 2 is 16, so the answer to this one is positive 16. Okay? So negative bases are kind of strange. Here's another pattern to notice. If the power is even, the answer is positive. If the power is odd, the answer is negative. Let's test that. See if you can do this one. Negative 2 to the fifth power. Pause the video. Okay, let's see how you did. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Did I get 5? Yeah, there's 5 of them. Okay, so after this operation, the answer is positive. Then we multiply it again, it becomes negative. Then we multiply it again by that one, it becomes positive. And the last multiplication is going to be making it negative. And we know that 2 times 2 times 2 times 2 times 2 is 16. So the answer to this one is 32. So the answer to that one is minus 32. So it does hold. Odd powers of negative bases give you negative results, whereas even powers of negative bases give you positive results. So now I want to talk about a weird thing about the notation that can get you in trouble, okay? If I write that, you might be tempted to think it means the same thing as this. Unfortunately, it does not. What this means is negative 1 times 2 squared. Okay? The negative is not included inside the parentheses for the power to operate on. And if you remember your order of operations, exponents come before multiplication. So in this case, we square the 2 and then we multiply by negative 1. So in this case, it's the same result. No, I'm sorry, it's not the same result. Notice how when we squared negative 2, we got positive 4. Now we end up with negative 4. In fact, no matter what you do, your answer is going to be negative. So if it's written this way, without parentheses around the base, and the negative is not inside, then it means this. And that negative gets applied at the end, and they're always going to be negative. So keep a lookout for that. In your homework, you will undoubtedly see 1 or 2 problems that are like that. Okay, let me give you some to try. negative 3 to the 4th power. Pause the video. Okay, let's see how you did. This is negative 3 times negative 3 times negative 3 times negative 3. Even power with a negative base means my answer is going to be positive. And 3 times 3 is 9, times 3 is 27, times the last 3 makes 81. So the answer of this one is simply 81. Here's another one to try. Let's just do negative 4 to the 3rd. Okay, pause the video. Do negative 4 to the 3rd power. Let's see how you did. This one's negative 4 times negative 4 times negative 4. So I have an odd number of negatives, so my answer is going to be negative. And 4 times 4 is 16, times 4 is 64. And it's negative. Okay. Okay, the second topic for today's lesson is prime factorization. And we do this with exponents in the following way. 12, if we want to factor it into prime numbers, let's start with the first factorization. We all know that 3 times 4 makes 12. However, 4 is not a prime number, so let's do that. Let's make it prime. Okay, so now we have only prime factors of 12. 3 times 2 times 2 does make 12. But now that we know about index notation, we can make this a little more simple. Because we know that 2 times 2 is 2 squared, so I can write 3 times 2 squared. Okay? Let me give you one to try. 20. Pause the video and give it a shot. Okay, let's see how you did. 20 is 5 times 4. But we know again that 4 is not prime. So that becomes 5 times 2 times 2, which then is 5 times 2 squared. Okay? What do you think? Let's try another one of these. They're tricky and they will pop up from time to time in this chapter. Let's try 48. There's a bunch more factors of this one. Pause the video, see how you do. Okay, let's try that one. I'm just going to factor it step by step. 48. Let's see. That's 12 times 4, or 4 times 12. Now, both of these are not prime. So let's do this. 2 times 2, that gives me my 4. What's 12? 12 is 3 times 4. Am I there yet? Not quite. I still have a number that's not prime. So let's fix that. 2 times 2 times 3 times 2 times 2. So that 2 times 2 takes care of that 4. If you were to put this into your calculator, you would end up with 48. Okay, let's test that. 2 times 2 is 4, times 3 is 12, times 2 more is 24, times 2 more is 48. So this is correct, that's 48. Let's finish. You want to use exponent notation, index notation. I have 1, 2, 3, 4 2's. So it's 2 to the 4 times 3. So that would be the prime factorization in index form of 48. That's all I have for you today. Thanks for watching. If you liked the video, give me a link down below or subscribe.